Section 9.9 is representations of functions as power series. In the last section, we were given a power series and we were asked to figure out what the interval of convergence is. Now what we're going to do is look at converting functions into power series. Now, the way that we're going to do that is using the sum formula for a geometric series. Recall that a geometric series is the sum from n equals 0 to infinity of a times r to the n, and that this geometric series converges if the absolute value of r is less than 1, and that the sum of the geometric series is s is equal to a divided by 1 minus r. So what we're going to do is we're going to look at functions that are rational like this, and we're going to convert them into this sum formula, figure out what is a and what is r, and then change them into a series. So let's consider this function here. Let's consider 1 over 1 minus x. We can rewrite this rational function as a geometric series. Notice that a would equal 1 and that r would equal x. Therefore, 1 over 1 minus x would equal the sum from n equals 0 to infinity. Instead of a, I would write 1, and then instead of r, I would write x, and that still gets raised to the nth power. Now I don't need that 1 there, so we know that this is really just the sum from n equals 0 to infinity of x to the n. So this series represents this function. If we wanted to find the interval of convergence, we would use the fact that a geometric series converges if the absolute value of r is less than 1. Well, in this case, r is the square root of x, so our interval of convergence is going to be where the square root of x is less than 1, because again, our r is x. Well, I know how to solve this. This is an absolute value less than inequality. It's sandwiched between the positive and the negative of 1, so this is just negative 1 is less than x, which is less than 1. We're already solved for x, therefore that interval of convergence would be from negative 1 to 1. Now, with power series, where you're using this geometric formula to come up with a power series, you do not check the endpoints. And the reason that you don't check the endpoints is because we know that the geometric series will only converge if the absolute value of r is less than 1. If it's equal, if there was an equal to there, like this, then it would diverge. So we can't use the equal to, which means neither of the endpoints can ever be included when we're using this sum formula to come up with our geometric series. Now, let's look at finding the power series for the function centered at c, and then determine the interval of convergence for those power series. The first one has us looking at f of x equals 1 over 2 plus x, and it wants us to center this at 0. Recall that sum formula for a geometric series is s is equal to a over 1 minus r. So the goal is to get it into this format. Well, how do you do that? Well, the first thing you do when you're trying to create a power series for your given function centered at c is center yourself first. So here I'm centered at 0, so if you look here, this x, it doesn't have anything in parentheses with it, which is perfect, so I'm centered at 0. So your first step is to center. After you're centered, the next thing that you're going to want to do is to make that a negative sign. So you want a minus in front of your x. The second thing to do is to get the minus sign. Well, I don't have a minus sign in front of my x, but I can just rewrite this as 1 over 2 and then minus a negative, because minus a negative is the same as a positive. And now I have that minus sign that I need. The last thing that you do is you make this guy here into the number 1. Well, I don't have a number 1, I have a number 2, so I'm going to divide everything by 2 to get that to be a number 1. So the third step is to get the number 1 in the denominator. If I divide everything by 2, I end up with f of x is equal to 1/2 over 2 over 2 is a 1, and then minus negative x over 2. Now I am in the correct format, a over 1 minus r. In this particular example, I know that my a is equal to 1/2 and that my r is equal to negative x over 2. So if I'm putting this into the series formula, I know that 1 over 2 plus x is going to equal the sum from n equals 0 to infinity of a, which is 1/2, times r, which is negative x over 2, raised to the nth power. And you can leave your formula like that. Sometimes you'll see the book say if this guy here is negative, they'll take it out and write it as negative 1 to the n and then times x to the n. And since the denominator is the same, we have a 2 to the n and a 2 to the first power, they'll write the denominator as 2 to the n plus 1. Again, this answer or this answer is the same and either is accepted. So the power series for 1 over 2 plus x centered at 0 is this guy right here, the sum from n equals 0 to infinity of 1/2 times negative x over 2 raised to the nth power. Then I'm asked to find that interval of convergence, and then it says to enter the answer using interval notation. Those are just the instructions for WebAssign. So let's find that interval of convergence. I know that for a geometric series, it's going to converge where the absolute value of r is less than 1. Well, I know what r is. R is negative x over 2. So it's going to converge where the absolute value of negative x over 2 is less than 1. Well, I have the absolute value there. If I have the absolute value, then I can get rid of this negative because the absolute value of a negative is just the positive. Now I have that absolute value less than inequality, and that becomes the compounded inequality, so we say negative 1 less than x over 2 less than 1. Finally, solve for x by multiplying everything by 2, and you get negative 2 is less than x, which is less than 2. You do not check the endpoints because you figured out what the power series was by using the geometric series. Therefore, you can just jump to the interval of convergence being negative 2 and 2, neither one included, so parentheses for both. Let's look at number 2. Now the only difference between example 1 and example 2 is that here in example 2 we want to be centered at 1. In example 1 we had the exact same function 1 over 2 plus x, but we were centered at 0. So the end result is going to be different because we're centering ourselves somewhere different. The first thing we need to do is center ourselves first. So I have to center first. Well, remember, when you're centered at x equals c, what that meant is that you were looking at an x minus c. So what I need to do is I need to make this x be an x minus 1. We write f of x is equal to 1 over 2 plus, and then instead of just x, I need it to be an x minus 1 because I need to center myself at 1. But now I'm unbalanced because I've subtracted 1 from my denominator, but the expression is unbalanced until I do the opposite operation. If I subtract 1, the opposite operation would be to add 1. So in order to balance that denominator, I need to do the opposite of a minus 1, which was my plus 1. And now I'm balanced again. Combine like terms, and you end up with f of x is equal to 1 over 2 plus 1 would be 3 plus x minus 1. After you've centered yourself, you get the minus sign in front of the x. So I need this guy here to be a minus sign. And just like we did before, we're going to rewrite this as minus the negative, because we know that minus a negative is just that positive. Third and final step is to get 1 in the denominator. So I have to change this 3 into a 1. Therefore, I'm going to divide everything by 3. This by 3, this by 3, and this by 3. Therefore, I have that f of x is equal to 1/3 over 1 minus the negative of x minus 1 all over 3. Now that I'm in the correct format, I know here that my a is going to equal 1/3 and that my r is going to equal the negative of x minus 1 over 3. So what I need to do is plug that into the summation formula, and we know that that's going to be that 1 over 2 plus x is equal to the sum from n equals 0 to infinity of a, which is 1/3, times r, which is this negative x minus 1 over 3 raised to the nth power. Now I'm asked to find the interval of convergence. Well, that interval of convergence, remember, is found by the absolute value of r less than 1. That means that the absolute value of the negative of x minus 1 all over 3 has to be less than 1. Well, I don't need to worry about that negative, and I'm an absolute value less than inequality. I change into that compounded inequality, and I write negative 1 less than x minus 1 over 3 less than 1. To solve for x, I multiply everything by 3 first. Negative 3 less than x minus 1 less than 3, and then finally add 1 to all three, and you get negative 2 less than x, which is less than 4. Therefore, that interval of convergence is going to be from negative 2 to 4. Again, you do not check the endpoints with the interval of convergence for these because you're creating a power series from a geometric series formula, and we know that a geometric series, if you were equal to 1, if this were equal to, it would diverge. So you can never be equal to 1 when you're creating these power series from that geometric formula. Now I also want to show you visually what we're doing. So we had two separate series that we're looking at here. The first one, and I'll highlight that in pink, is this 1 over 2 plus x was equal to the sum from n equals 0 to infinity of 1/2 times negative x over 2 raised to the n. And the other one, which we'll highlight in green, is 1 over 2 plus x is equal to the sum from n equals 0 to infinity of 1/3 times the negative of x minus 1 over 3 raised to the nth power. The one on the left, the pink one, is centered at 0, and the one on the right, the green one, is centered at 1. So let's go ahead and put this into a graphing calculator online so we have an idea of what it looks like. If we just go to desmos.com, the first thing I'm going to do is I'm going to put in the function that we're looking at, and that's going to be y equals 1 over 2 plus x. And then I'm going to put in our two different series. Now remember, the first series we had was the sum from n equals 0 to infinity. I cannot put infinity in here and have it work, so I'm just going to put in a slider, so I'll put the letter a there. And then we know that that was 1/2, and then it was times negative x over 2, and that was raised to the nth power. So this summation here, which is the blue line that you see here, notice as we get closer and closer to infinity, the blue graph wants to be this red graph. And remember, the red graph is the one that we initially started with, the 1 over 2 plus x. And it's also centered at 0. So notice that you're moving away the same amount of distance towards negative 2 and towards positive 2 centered at 0. Recall that the interval of convergence for that guy was from negative 2 to positive 2, not including 2 or negative 2. And if we added more numbers, let's say that we had our slider go to 100, notice again it gets closer and closer and closer to being that red graph. Right, let's put in the other summation formula that we found when we were centered at 1. So we were looking at the sum from n equals 0 to, let's call this b to give it a different slider, and this is 1/3, and we were multiplying that by the negative of x minus 1 over 3, and that was raised to the nth power. And if I add that slider, and this guy here is purple, notice that the purple graph wants to be the red graph. And remember, the red one is the one that we want. So let's make the blue one go away for a second, and let's make this guy go to about 100. So notice that as we get closer and closer and closer to infinity, this purple graph is becoming this red graph. And notice that it converges. It looks like the red graph from negative 2 all the way to 4, which is what our interval of convergence is. And we were centered at 1, so we move the same amount of distance to the left of that center as we do to the right of that center. So what we're doing in this section is creating a power series that mimics a function, but it's only going to mimic that function over a certain interval of convergence. In this case, for the purple one, it was from -2 to 4, and if we put the blue one back up, remember it was from -2 to 2.